Friends, in Dalton's law, I want to explain about the Dalton's law of partial pressure in the gas state. How to define Dalton's law, what is the numericals, what is the problem. I am clearly explained. According to Dalton's law of partial pressure is equal to, that is, if you take any vessel, you take different gases, that must be mixture of non-reacting gases. They cannot react. If it is reactive, that is, this law is not applicable. If you take any mixture, hydrogen, oxygen, helium or anything, but this is not reacted, the pressure exerted by each individual, total pressure is equal to the pressure exerted by the each gas, that is oxygen, hydrogen or helium, etc. That is pressure, total pressure is equal to partial pressure of P1 plus P2 plus P3. This is the Dalton's law. If you take two different gases, how to derive this formula? Number of moles N1, if you take number of moles of N2, gas 2, these two are must be not reacted at constant volume and constant temperature. If you take this vessel, is volume is fixed, temperature also constant. This gas 1 is exerted by pressure P1, this gas 2 exerted by the pressure is P2. If you write it, is P1 into, according to ideal gas equation, PV is equal to nRT. Here gas 1 exhibit pressure P1, V is equal to N1 into RT. For this gas, P2 is V is equal to N2 into RT. These are the two equations. If you want to write it, total pressure P total is equal to volume is fixed, that is equal to number of moles N1 plus N2 into RT. These are the three equations. If you add these two equations, second and third, we get volume into P1 plus P2 is equal to N1 plus N2 into RT. That is total pressure. P1 plus P2 is total pressure is equal to into V is equal to N1 plus N2 into RT. If you divide second equation with first one, this P1 by P total is equal to V is cancelled, N1 by N1 plus N2. This is the mole fraction of X1. This is P1 is equal to PT total pressure into X1. If in case of second gas, P2 is equal to P2 into X2. These are the two different gases, two partial pressures and their mole fractions. If you divide with P1 by P2 is equal to P total into X1 by X2. P total will be cancelled, that is X1 by X2. That is equal to number of moles of N1 by number of moles of N2. This equation is very, very important. We get the problems by using this equation, number of problem. If you take one problem, equal masses of helium and methane are mixed in a container, then we have to find the fraction of total pressure exerted by the helium. For this, you take helium and methane. If you take these two masses are equal, for example, if you take 16 grams, this is also must be taken as 16 grams because equal masses. The number of moles is equal to weight by molar mass, molecular weight, that is 16 by 4.